Okay, welcome to this first homework video. So this is problem, oh boy, let's see, problem 13 in chapter 12. So we've already done this. I had done this in one of the lecture videos, but I thought I'd go over it again just to, I don't know, make sure we all got it. But we're going to create that simulation for the Portacom, what is it? Yeah, Portacom simulation that was in the book. So we have a price for our product of $249. We have a fixed admin cost of $400,000, a fixed advertising cost of $600,000, and then our parts cost were uniformly distributed with a lower bound of 80 and an upper bound of 100. Our labor costs had that, that unique probability. Remember that was sort of assigned. And so here, just to remind you, this is going to be my VLOOKUP table. You're going to put in your lower bound here in column 1, and then your cost will be in column 2. And then here I have my demand. This was normally distributed with a mean of 15,000 and a standard deviation of 4,500. So I think I said this in the lecture video, but let me just reiterate. When you're setting up these simulations, you want to try to keep them as flexible as possible. And so what I mean by that is, create all these input cells so that when we do the simulation down here, I can reference all of this information so that if anything changes, right? Like if the price were to change, all I would have to do is go back and put in the new price and everything would update itself. Okay, so with that said, let's do this simulation. So for my demand, I'm going to use that norm.inverse function, right? So my probability, again, is the RAND function, open, close parentheses. And then my mean is simply, link it to this 15,000. And then my standard deviation is the 4,500. So hit OK. And then remember, I'm going to copy all this down. So I want to anchor the mean and the standard deviation for my demand. Okay, now my labor. So that's going to be my VLOOKUP function. And I'm going to reference this table. So I need to get my VLOOKUP. Let's see, I don't think that's in my recently used. Nope. So VLOOKUP. All right, there it is. Okay, my lookup value. So remember, this is where I want to put in my RAND function, right? I'm going to randomly generate a number between 0 and 1. And then my table array, that's this whole table. So here, let me get this out of the way. So highlight the entire table. And then remember my column index number, this is the column that I want Excel to pull from. So in this case, I just have the two columns. So the first one is going to be where it looks it up. And then I want it to pull from column 2. And then remember for your range lookup, you want to type in true or leave this blank because I don't want an exact match. An exact match is either getting a 0.1, or I'm sorry, 0, a 0.1, a 0.3, 0.7, 0.9. I don't want that. So I'm just going to type in the word true. I got to find, there's my cursor, hit OK. There you go. Now same thing, because I'm going to copy this down, you want to do some anchoring here, right? So basically you want to anchor your table. So I'll put a $sign here, and there we go. All right, and then finally I've got my parts. So remember, my parts follow that continuous uniform distribution with a lower bound of 80 and an upper bound of 100. So I'm going to use that formula, right? So I'm going to take my lower bound, 80, plus, here, let me go down here so that you can see this formula as I type it out. 80 by plus my RAND function times the difference between my lower and upper bound. So here's my upper minus my lower. And there you go. So I'll highlight that again so you can see it. And then the same thing, I need to do some anchoring. So I'll anchor this lower bound and then the upper minus the lower. Voila. All right, and then finally, my profit. So my profit is simply going to be, in this case, it's going to be my demand, right, times my price of $2.49 minus my variable costs, which is labor minus parts, right? And then minus the sum of my fixed costs. So I go back up here and sum my fixed costs, and there. So let me highlight that again so that you can see that. So it's going to be, demand times price minus my variable costs, and then the sum of my fixed. Again, I need to do some anchoring here, but you have to be careful. I don't want to anchor my demand, because as I copy this down, I want to get all those new demands, right? But I do want to anchor my price. That's not going to change. That's the $2.49. I want my labor and parts to go with me as I copy it down, so don't anchor these. But then, of course, I want to anchor my fixed costs, because those aren't going to change. So I'll anchor that, and presto, now you are done. Okay, and let's see. Well, scribe, compute. Okay, well, we'll just do, say, 500. I think that's what it did in the book. So 500 simulations. So I'm going to copy this. And let's see. So 514 is where I want to go to. And you don't have to be exactly 500, to be honest with you. Because the law of large numbers is going to guarantee that the means and whatnot are going to be pretty similar, right? Because we've got so many observations here. Okay, there we go. So here are our 500 simulations, okay? And then what you want to do is, and I've got this set up for you, you always want to create this table, and this is the whole purpose of doing this, right? What is the mean profit? What's the standard deviation of that profit? What's the minimum profit? What's the maximum? Blah, blah, blah. So here, just use our average function. All right, average. There it is. Okay, so just take the average of all these profits. Voila. So on average, we're expected to make about 694,000. What's the standard deviation or the variation, right, in all these profits? So here, you want to take the standard deviation, but make sure you get the .s version of your standard deviation function, right? There's a .s and a .p. The .p is for a population data set. Since this is a sample data set, you need to use the .s. And yes, there is a difference between the two. Same thing, just highlight profit, so I'll do that. There we go. Hit OK. There you go. So I'll comma format this just to make it look a little nicer. There we go. All right, what's the minimum profit or the smallest profit? So this is the min function. There it is, min. And again, just highlight all your profits. So there is we could lose up to 786,000. And then a max. So just get your max function. Highlight everything. There we go. Ah, well, we could make about 2 million, so that's kind of nice. And then the number of losses. So here, you're going to use the COUNTIF function. So go in here and find your COUNTIF. There she be. COUNTIF. All right, the range here is the profit. So well, that's my range. Now, what's my criteria? Well, I want to count all of the profits that are less than 0. Now remember, when you do this, you have to use those double quotes for some reason. So double quote, less than 0, double quote again, hit OK. And that tells me, oops, let me make this a little bigger. Okay, so I've got, out of those, say, 500 simulations, 35 of those were losses. And then you want to do the probability of loss. So the easiest way to do this is to take the number of losses. The idea here, the probability of loss, is just the number of times you incur a loss divided by the total number of simulations. Well, the way we're doing this is just hitting the page down when you're copying. So the easiest way to do this is to use the count function. Now this is different. This is just the count function. So in other words, I just want to count how many simulations I've done, right? So just go to your function wizard and then get the count function. There it is. And then just highlight how many profits, or highlight the profit column. So you can see right here, I don't know, hopefully you can see this in the video, but I actually did 501 simulations, right? That's why it's nice to use the count function, because then you don't have to be exact. And that's what I'm trying to get at. Okay, so the probability of loss is 6%. So there is 9% now. So there, roughly about a 10% chance in this problem that the firm could experience a loss. All right? Now, just real quick, I'm almost done. But this is my point about keeping everything flexible. So, you've got this model set up, and then your boss says, well, what if the price goes up to, say, 251? So you just, to do that, literally just type 251. Everything will update because all of these functions are volatile. And so here, this is what it looks like if the price goes up to $251. And of course, anything and everything can change. If the probabilities and the cost for your labor change, it's easy. You just update this table, right? If the lower and upper bounds for parts change, well, just put in the new ones. And then same thing here. If the mean and standard deviation for the normal distribution change, you would just plug in the new numbers and everything would update. And let me just show you that. So let's say that the demand for whatever reason is up to 20,000. So you just type in 20, 1, 2, 3. And my point is now all of this is going to change. Hit enter. Presto. You've just resimulated everything once again, right? And that's what's nice about keeping these worksheets functional in that way. All right? All right, well, that's it. So that is problem 13. Actually, I got to do one more. What is your estimate of the probability of a loss? So I should go back, make that 15,000, make this 249. So my probability of a loss, I would say, is 0.08. And my suspicion is, even though you've done this on your own, my suspicion, because of the law of large numbers, all of these, the mean, the standard deviation, the min, the max, the probability, I would suspect that all of you got similar answers to mine. They're not going to be exactly, but your mean is going to be somewhere around 700,000. Standard deviation somewhere around 500, right? The minimum somewhere around 800, so on and so forth, all right? Why? Because we did so many simulations. All right, well, that's it. So there is problem 13 in its entirety.